Alright, welcome to our 9.1 video, part 2. We are continuing talking about quadratic functions. Today we will be graphing quadratic functions. So you can use the fact that a parabola is symmetric. That's going to help us graph these rather quickly. You can also use your graphing calculator, for those of you that have one. Using your y equals button, you can type in a function. So to begin, the first function we're going to be graphing today is y equals negative 3x squared. Okay, we will talk about the domain and range in a second, but first we are going to graph it. So you can see that we have a table of values. Most commonly, we have been plugging in negative 2, negative 1, 0, 1, and 2. However, since we know that parabolas are symmetric, we only need to do one side of our graph because the other side will mirror the side that we are working on. So for your x values, you can plug in 0 for x. In order of operation, 0 squared is 0 times negative 3 is 0. So that means our first point is 0, 0. Okay, if you have your graphing calculator, you could have typed this function in to your y equals and gone and hit second graph and pulled up this table for you. Okay, if not, you do have to plug in these x values. So now you will be plugging in a 1. Notice when I plug in, I am putting it in parentheses. Order of operations matter here. So you would do 1 squared, which is 1 times negative 3. That gives you negative 3. So our next point, x was 1. We just found that y is negative 3. Okay, continuing on, plugging in 2 for x. 2 squared is 4 times negative 3 gives us negative 12. So our next point is 2, negative 12. Okay, I only have 3 points here. I'm going to go plot those now. So on my x-axis, I am going to count by 1s. On my y-axis, because I need to get negative 12 here, I'm going to count by 3s. Okay, so I'm going to call this as negative 3, negative 6, negative 9, negative 12, etc. So my first point was 0, 0. The second point was 1, negative 3, and our last point was 2, negative 12. So this is one side of my parabola, but since we know parabolas are symmetric, I can mirror it on this side. So another point would be negative 1, negative 3, and negative 2, negative 12. And I've now formed my dots to form my parabola, which remember is a U shape. So you would connect your dots to make a U shape. Hopefully yours looks better than mine. They do include arrows because it will continue to keep going. Okay, so this is graphing a parabola. They will be U-shaped. They will be symmetric. Okay, make sure that you are creating your table to find your points. Now the question does also ask about domain and range. You may or may not remember those words from previous chapter. Domain means your possible x values of your graph. Range then is possible y values of your graph. So of my parabola that I just graphed, these arrows symbolize that it will keep going. So x could keep going this direction and this direction. So our domain, which we'll abbreviate D, is actually going to be what we call all real numbers. All real numbers. What that means is there's any option for x. Okay, it could be a negative, it could be 0, it could be a positive. X is going to keep going in both directions for our graph. Okay, so on our x-axis here, we'll still have values going this way and this way. However, our range is the possible y values. And if you notice, this is our vertex. It is a maximum, which means y will never be greater than this value right here. So we would write that y is less than or equal to 0. So what that means is that y values for this graph could be anywhere down below 0, anything at all. So like we had negative 3 as one of them, we had negative 12. We would never have anything above 0, as 0, 0 is our vertex.
Going through the next problem, We notice we have a fraction on this one that we need to graph. You notice the points on the side that we're going to be using for our x values are a little bit different. We're not using 0, 1, and 2 anymore. We're using 0, 3, and 6. The reason for that is if you look at your fraction, we're using 1/3 as a fraction. We want to use numbers that are going to work out nicely for us. So if you multiply, use your x value for something that is a multiple of your denominator, it's going to give you nice even numbers or whole numbers, not decimal, for that. So if we're going to use 0, plugging in 0 for our x value, we have 1/3 times 0 squared. Again, making sure that you use your parentheses. 0 squared is 0 times 1/3 is 0. So our first point is going to be 0, 0. Plugging in 3, we have 1/3 times 3 squared. 3 squared is 9. Well, 9 over 1 times 1 over 3 is 9 over 3, which that simplifies to 3. So our point would be 3, 3. And the last one that we're going to use is 6. So 1/3 times 6 squared. 6 squared is 36. And 36 over 1 times 1/3 is 36 over 3, which that simplifies to 12. So our last point that we're going to be using is 6/12. So we'll go over to our graph. Again, on this one, we will count by 3s for our y value. For our x values, we will also count by 3s. So our first point that we are going to graph is 0, 0. The next one we are going to be graphing is going to be 3, 3. And then our last one is going to be 6, 12. And again, like we talked about last slide as well as yesterday, the parabola they are symmetrical, so we can go on the other side, and we're going to have -3, 3, and -6, 12. Now we have our points, so we can draw in our U-shaped graph. And then now let's talk about our domain and our range. Like Ms. Burbridge just talked about, the domain is talking about all the possible x values that we can have. And again, our x values are going to continue to go up on both negatives and positives. So again, it is going to be all real numbers. And then our range value, our vertex is at 0, 0. This time is a minimum, so we will never go below the x-axis. It's going to be above the x-axis. So this time it's going to be y is greater than or equal to 0.
All right. On this page, we will be comparing the widths of our parabolas. So this says use the graphs below and order the graphs from widest to narrowest. And they're giving you the equations right here. And instead of graphing them yourselves, they have included the graphs for you. So you're looking for the graph that is the widest, which you should notice is the middle one. So I'm going to label that a 1. It's the first one in our order from widest to narrowest. Okay, the second graph then would be this one, f of x equals x squared. And then this one is our most narrow one in third place. So let's look specifically at the equation and what would make these graphs wider or narrower than each other. So off of our parent function, if you remember that term, f of x equals x squared is our most basic quadratic function. This graph here, a is 1/4. The closer that a is to 0, the wider your graph will be. Okay, the closer to 0, the wider your graph will be. So since a is 1/4 here, closest to 0, the graph is wider. If you look over here, being that a is -4, despite the fact it's negative, okay, it's actually much narrower. So if you think of it this way, this is taking your x values and then taking 1/4 of them, making them much smaller. That's why your graph is narrower. This is taking your x values and multiplying them to get a bigger number, which is why your graph is more narrow. This one is the widest. Okay, so at this point, I would pause and do the got it yourself to check the order. You're ordering them from widest to narrowest, okay, and then replay to check yourself. All right, so in checking yourself, you should have said that this graph will be the widest graph. This value is closest to 0, okay, followed by this graph, -x squared, and then 3 is furthest from 0, so it would be the most narrow graph. So you will tune into our next video to continue 9.1 Part 2 notes.